Okay, so today I'm going to present on plyometric training concept for the performance enhancement. Okay, why I want to talk about this thing because last week I was mentioning about muscle spindle, the anatomy and the function. So basically, the exercise involves or any movement involves we use as at the daily application usually we use plyometric, and the other term we can use is the SSC lah, so which is the strength shortening cycle. So the strength shortening cycle usually when you're walking, running, for athletes, for sprinting also when can be used lah. So basically plyometrics and SSC is the same. So plyometric training is for the athletes basically. So what they meant by plyometric is plyo means is a more, metric means is a measure. So that is in the Greek word itself. So the definition wise is exercise that involves repeated stretching and contracting muscles. So in order to increase the strength. So there is the stretch reflex I already mentioned last week. It's a monosynaptic, so there will be a contraction as well lah. So if stretching it always involves muscle spindle, but for contraction it always involved with muscle fibers. So I'm not going to touch about the muscle fibers today, but I will talk about it in next few sessions next week lah. So basically what is muscle fibers, the contractile elements, mechanism, basically the cross bridging and also the sliding filament theory, which is very important as well in the plyometric training concept now. So example of plyometrics usually is like skipping, jumping rope, hopping, lunges, jump, squats. So the plyometric and SSC is the same. Okay, it utilizes the SSC actually. So if you see the SSC is like there is a three phases. So there is the eccentric, amortization, and also the concentric. So if you see the eccentric, usually it will go for the lengthening, and the amortization is usually the transitional period for the eccentric and the concentric. So if you know the contraction, there is few. So if you see contraction wise, there is a isometric and also isokinetic and also isotonic. So if this is the pure contractions that we call it. So this isotonic, usually the tone will be the same. So the length isotonic means iso same, tonic is the tone lah, so the muscle tone is the same lah. So if you see the isometric is like the length is the same lah, so metric and the iso, so it's the iso means same lah. So isokinetic usually we use the utilizes the machine usually like a CPM, so that's 2 CPM. So then that is isokinetic lah. So in this SSC, so there's two, which I talked just now is concentric and eccentric. So first we see the definition first lah. So the definition wise is a rapid cyclical muscle action whereby muscle undergoes eccentric contraction followed by transitional period prior to the concentric. So it is called as a pre-stretch or counter movement. So it's a reverse action of a muscle actually lah, they call it. So this is my picture actually lah. So the first phase you will be the first two phase you see will be eccentric. So eccentric first, then the second this one will be the amortization, and then the last one will be the concentric. Okay, so this SSC works like a spring-like mechanism now. So this is the mechanism, like if you see a spring, right, so we put a force here, so you try to push, so then it will will rebound, okay, then it will go up again lah. So yeah, you see this one. Yeah, so compression of coil causes it to rebound, okay, and then the jump off a surface or in a different direction lah. So if increased speed at which coil is compressed, or how hard is it pressed down, it's usually amount of force applied will result jumping higher or further. So if you put higher force, so you will get the output as a higher output as well lah. So that is we call as a rate of loading. So that is very important actually lah. So this SSC, they have two types actually. So based on the duration of the ground time lah. So ground contact time. So the fast one is less than 250 milliseconds, and the slow SSC is more than 250 milliseconds lah. So examples for the fast SSC, like sprinting, it only causes about 90 milliseconds like that, and long jump, multiple hurdle jump, that's the example of the fast SSC. For the race, slow SSC is usually race walking lah. So there's actually a lot of mechanics that in responsible for the performance enhancement of SSC lah. So the first three things that I will explain is this: storage of elastic energy, neurophysiological model, and active state. So actually this is like one topic itself lah. So but this one is not a brief one. So I'll just explain it roughly, and I'll explain in next session about the storage of elastic energy, because we need to know the muscle fibers, the contract elements, all the mechanisms before I try to explain further on in all these three things lah. So this storage of elastic energy is basically like a stretch rubber band lah. So amount of force to the stretch band is equivalent to amount of force which is produced by the band lah. So basically this is in order to return to the pre-stretch state lah. So the tendon is the primary site for the storage of the elastic energy. So it cannot be contracted, and it remains in a state of tension, this tendon lah. So usually for SSC, the muscles must be remain contracted for the first two process of SSC. So in order to transmit the isometric forces into tendon, so it hence causing the deformation and lengthening of tendon lah, and development of storage elastic energy. So during the concentric phase, which is the last one, so muscle will be able to contract concentrically and provide additional propulsive force. So let's say if the first two phases, which is the eccentric and also the amortization, so if there's failing to stiffen, so the performance will drop, and the range of motion will be reduced lah actually. So the neurophysiological model. So I think I mentioned about proprioceptors in muscle. So basically last week I was talking about the anatomy and the function. So the proprioceptors in muscle is muscle spindle. So what they do actually, they send the information to brain for regarding the changes of length and the tension and the joint angles lah. So proprioceptors in tendon is GTO. So this one, there's a mechanism actually lah. So when muscles forcefully lengthen, muscle spindle will be engaged stretch reflex response to prevent the over lengthening and limit the possibility of injury lah. So then it will increase the recruitment of motor units and increase the coding effect. So and then it causes those neural response to be excited and causes to the concentric force output to be increased. Then hence it will enhance the power output during the sporting movements. So due to the inhibitory stretch reflex response of the GTO, so which was, I think I mentioned about last week I think. So the contraction of action of the muscle spindles. If so, the GTO will inhibit the muscles high muscular stiffness needed during the SSE, and hence they will reduce the concentric force output and the performance will drop as well. So let's say now the athlete's been doing plyometrics but longer, like about 4 months. So this GTO disinhibition will be reduced, and also the muscular pre-activity will be increased, and the stiffness also will be increased lah. Okay, the last one is the active state. So this is the what we meant by this active state is whereby the time period of time in which force can be developed during the eccentric and the amortization phases of SSE. So which is the first two phases lah, before the concentric contraction occurs. So the longer eccentric and amortization phases will have more time for the formation of cross bridges, and will cause more enhancing joint moments, and will cause increased concentric force output. So this is kind of a formula lah, impulse equivalence to force times time. So I think that's all I'm going to talk. Okay, so the next week I'll be talking about the mechanical about the muscle fibers, skeletal muscle, and the mechanic properties of the skeletal muscle, and how they enhance the performance.